Design of experiment quick guide. 10 things to know. We're going to discuss each and every factor. Let's start with the first factor. Set acceptance criteria. How much you would like to have. For example, 95% confidence. That means you can live with 5% risk, right? Or if you wanted to widen or tighten, both are possible. For example, 90% confidence. That means alpha is going to be 10%, right? So based on your requirement, you can adjust alpha error. Second thing is that select factors. Choose factor carefully with the help of hypothesis testing. As much as possible, filter it down so you can perform with a less factor, you can optimize the design, and you can optimize the experiment and so on. Define level. Generally, in design of experiment, binary is suggested. For example, even if you have a variable data or continuous data, you can convert back to binary, right? Pick up two level, like for example, low, high, on, off, 0, 1, 1, 2, and so on. Fourth factor, plan sample run. For example, for sample run, you can have a readily available simple formula. Number of runs equal to L, that is level, to the power of factor. How much factor you have? For example, you have two level, two factor. That means number of runs you need to do it is 4, right? 2 the power of 2 is 4. And similarly, if you want to repeat the same thing, you can do that. Replicates is always good idea, right? Or if you have too much factor, you wanted to cut it down through the fractional, or you wanted to use ortho design, or you wanted to use so much factors you wanted to use Plankett-Burman method, you can still use it. Fifth factor is randomize order. Why it is very important? So that shuffle the sequence to reduce bias. Sixth one is run and record data. So each time when you do that experiment, track the result, what context, what settings. For example, you may shift the operator, lots, conditions, and so on. And some variable, you can keep it constant. For example, you have studied some parameter in rainy season. So that means you try to cover complete in the rainy season so that your noise factor will not get influenced. Seventh one, analyze the data. Use review the analysis of variance. Use signal to noise ratio, which will guide you to retesting and all that. If the noise is high, you can do the retesting that particular run. And then you have that factor. For example, if the significant value less than alpha value, then it is significant. For example, if it is, let's say you set alpha as 5% and you are getting p value less than 5%, let's say 3%, that means it's significant. Other than that, it is not significant. Visualize the result, right? Check the interaction plot. In the previous video, I talked about interaction. Maybe you can use boxplot, ANOVA, and try to see the interaction, whether it's been interaction 3, that is fully intersect, is there or not. Confirm the finding. How you do that? You validate with another DOE, and meaning you repeat the experiment or follow-up test, retest the borderline result, because it could be due to hunch. You don't want to take any risk, so you can retest borderline results. And the last and final point is that refine, reduce, right? Focus on most significant factor. Right? Pause and reflect, learn from mistakes, whatever the mistakes you have done, learn from the mistake. This is how you can make the design of experiment great. We should have a great learning on design of experiment. And what is up next is design of experiment checklist. So we have jotted down all CTQs. It is really, you can use it, and you can still make the active notes during your experiment. Stay tuned for more content coming up soon. Thank you so much.